Hi everyone, my name is Jessica Van Brummelen and I'm a PhD student at MIT in the MIT App Inventor Lab. And I'm working to democratize conversational AI, whether that's for K-12 education or for others who are interested in using and developing this technology. And so today I'm going to talk about the importance of AI education, 3 conversational AI tools the App Inventor team and I have developed to democratize AI, what we learned through these tools, and then also what we believe is important for others to learn about conversational AI, and how we can actually do that. So first, I'd like to talk about the motivation for this research. Number one, as conversational AI researchers, we're pushing the boundaries of conversational agent technologies and moving from the first levels of AI assistance to higher levels, which will likely lead to exciting innovation and growth. And as with any technology, as it increases in complexity, this also leads to new ethical concerns. So for instance, you might remember Google Duplex and the ethical concerns over a very realistic agent speaking over the phone to someone. And so with these advances, as much as it'll lead to new innovation and potential for good, there's a growing need for AI education, really teaching people what it means to live in an AI-filled world and how conversational agents work and the ethics of this technology. And so today I'm going to talk to you about the 3 applications I developed with the MIT App Inventor team to teach K-12 students these things. And so the first project is the Alexa Skills interface. It's a tool within MIT App Inventor, which is an open source website that anyone can use to create their own mobile phone or tablet apps that allows students to drag and drop code blocks, as you can see in the picture, and create conversational agents as Alexa skills. And so the code blocks actually simplify programming, lower the barrier to entry, and really allow us to teach AI in a highly learning-friendly environment. So what I actually did with this interface was teach around 15 high school students how to create Alexa skills that could connect to mobile devices and apps that they actually made. And something we taught the students was how to contextualize these assistants, bringing them closer to level 3 by transferring data between the mobile phone app and the Alexa device. And so we did this through a database called CloudDB. And one of the examples we actually showed in class was a storybook application that you could program and also talk to about with Alexa. So if you're on the page of the story that's shown on the left side of the screen, for example, you could ask Alexa, what's going on in the story right now? Or who's Caribou? And so on, and get that contextualized conversation. So now I'll show you a video where I create a simple Alexa skill with MIT App Inventor. And the Alexa Skills version of this website isn't yet public, but it will be soon. And you might notice that I don't create an app associated with this Alexa skill, but that's completely possible and something that students were actually able to do.
App Inventor's mascot is a bee named Cody.
And so we ended up bringing this interface into a workshop environment where high school students use the interface to create their own Alexa skills. And they created some really, really cool projects, including a memory helper, as shown in the picture to the left. And this one student actually developed this skill to help his mom, who had difficulty remembering words. So she might say to the skill, "I'm trying to remember a word that's a fruit, that's growing in an orchard." And Alexa would try to guess the word she's thinking of and say something like, "I think you're referring to an apple." And another skill was called "Can I recycle this?", which would basically help people to learn how to correctly recycle items. So, for example, you might ask it, "How do I recycle this battery?" And it might respond, "You can recycle a battery by taking it to a recycling depot, like Big Green Box on Com Ave, and so on." And then another example was actually a specialized calculator skill, which would, instead of directly giving you the answer to questions, math questions, it would actually give an explanation of how to get the correct answer. So, for example, you might say, "What's 9 times 6? And it might respond with, "9 times 6 is 9 groups of 6 things, which adds up to 54. And so with the workshops, we actually completed a study with the students. And here are the key takeaways that came out of that study. So even young students can actually learn about complex topics like machine learning and generative LSTM models. And we taught students about generative AI, as in the slide below there, and other machine learning concepts. And students responded to survey questions with their own explanations of machine learning. And so one example was that machine learning evolves as it gets more experience, and rule-based AI provides the same results every time. So as you can see, students actually learn these concepts by going through the curriculum and developing their own Alexa skills. And so generally speaking, students found AI concepts challenging, as you can see by the quote beside there, and especially the terminology that came along with it, like intents and invocation names. Those are pretty confusing at the start. But students were nonetheless able to develop complex projects. And as shown before, they could actually learn machine learning and other AI concepts, which was really exciting. And then finally, students were really optimistic about the future of conversational AI and had exciting ideas for future agents, which I'll actually describe later on in the presentation. But for now, I'll just give a quote from one of the students, basically that conversational agents are capable of solving problems and helping people. And then if you're interested in learning more, you can look at that URL below, and there's a paper linked there. And then the second project was to actually create a conversational agent that was teachable that we called Zorai. So it was designed to help 3rd through 5th graders learn about machine perception, learning, and natural interaction. And in the video on the next slide, you'll actually see how it works and how visualizations and interacting with Zorai and actually teaching Zorai helped kids learn. So I'll show you that now.
Hello.
Hello, I don't remember meeting you before. What's your name?
Jessica.
Nice to meet you, Jessica. Where are you from?
Kelowna in Canada.
Canada sounds interesting. I'm from planetic Brummelen, so I've never heard of Canada before. Tell me more.
What do you know about the rainforest?
Oh yes, rainforests are very interesting. Here's what I know.
Spiders eat bees. Bees eat nectar. Bees make honey.
These sound fascinating. Now I want to visit Earth and all of its life. I'll show you what I understand after I think for a little while.
Where do bees live?
Oh yeah, bees sound interesting. Let me think about where they might be from. Based on what I know about Earth, I would guess bees live in deserts.
And so we ended up doing a pilot study with 14 3rd to 5th grade students and came up with a few key takeaways. The first is that by allowing the agent actually to make mistakes, students learned about the reality of AI, that it's not perfect and it's only as good as the data that it learns from. And it also piqued their curiosity. So, for example, in this case, the agent thought camels lived in the ocean, which clearly isn't right. So students got to go back to the data, figure out why the agent might have thought something that's incorrect. And in this case, it was likely because many of the sentences it was trained on contain the word water. And those are sentences that students could actually input and change and see how the agent responds with different data that it had been trained on. And so the second key takeaway from the study was basically the effectiveness of visualizing the system model. So it really opened up the model to interpretation, allowed children to draw their own conclusions, and really engage students. And so, for example, in the left visualization, students questioned why some of the bubbles were blue and why others were orange. And by going back to the data, they could actually determine that the orange was because the associated sentences contain words like not or very little, which made them negatively associated with the desert. So, for instance, deserts have very little water, made water actually appear orange. And finally, our third key takeaway was the effectiveness of learning by teaching. So by teaching someone or something, in this case, people solidify their knowledge and actually learn better themselves. And students might even look something up about animals, like facts about camels, to teach the agent and learn something new in the process just by teaching. And so learning by teaching is an awesome use case for conversational agents and other AI tools. And so again, these are the main takeaways from our user study, and more information about them can actually be found in the paper at that link below. And so finally, the third project for democratization is what we call Combo. Combo is a conversational programming agent, which basically means you conversationally speak to the agent in order to collaboratively create a program. So for instance, you might create a program that speaks the words "Hello World," as in the conversation on this slide. And basically, we developed this system with the purpose of teaching computational thinking and artificial intelligence skills, and lowering the barrier to entry to programming even further, so that you don't even necessarily need to be able to use a mouse and keyboard in order to program, but you can rather use your voice. And so I'll show you an example of creating a simple program with the system, and then I'll talk more about the study we actually completed with it.
Create a procedure.
What do you want to call the procedure?
Hello world.
What do you want to happen in the procedure first? You could make me say something. See the sidebar for more options.
Say, tell me something to repeat.
Added action to the procedure. Do you want to do anything else?
Listen for user input.
What variable name do you want to save the input as?
Echo.
Do you want to do anything else in the procedure?
Say the value of echo.
Added action to the procedure. Do you want to do anything else?
Done.
I finished creating the procedure. You can say, run hello world to play it.
Run hello world.
Tell me something to repeat.
Hello world.
The value of echo is hello world.
So in the study with this system, we mainly looked at the interaction modes people would use, varying it between keyboard input, audio input, and a combination of both. And we also started the conversation-driven design process, collecting example utterances from real users and looking at how people might interact with Combo in the future. And the main takeaways we found in this study, which can really be generalized across most conversational systems, are to make the system flexible and accessible. So, for example, giving people the opportunity to use voice to interact, as this was seen as an efficient mode of interaction in the study, and also the opportunity to use text to interact, as it was often more accurate than the speech recognition. And also to make a transparent system, so providing users with the ability to ask the system about itself. like how speech recognition works or how the user can speak differently in order to help the system understand better. And if possible, also including visualizations like program overviews, especially since users are often very familiar using visual interfaces rather than voice-first interfaces. And finally, add speech recognition and natural language understanding improvements when possible. So we found that despite using one of the gold standard models in current speech recognition, users' biggest frustration was actually incorrect recognition. So one opportunity to improve the system would be to create a model that's programming specific, or whichever use case you're engaging with, that it's specific to that. And so it might be trained on phrases that are specific to that particular use case. So for example, for programming, it might be like phrases about creating a variable, like create variable var, or if the variable is greater than ... and so on. And so I've talked a bit about what we've learned from developing these systems, but something that I also think is incredibly important is what exactly is it that we want others to know about conversational AI? And what are the most important concepts for people to know right now about conversational agents? So as a first step, to demystify the magic box of Alexa and other conversational agents, we need to teach people core conversational AI concepts, especially because people often really don't understand what agents are and what they're not capable of. So for example, before developing their own conversational agents, some students in our study thought Alexa was more intelligent than they were and thought Alexa could actually do anything on the internet. And so the first concept we want to teach is that agents don't automatically understand speech. We first have to sense it and actually make it machine readable. And so one example of teaching this is actually letting the conversational agent describe these kinds of concepts when asked. And so with Convo, we actually just recently implemented a BERT Q&A model with a context paragraph about how Convo actually works. For example, a student can ask Convo, "How do you recognize my voice?" and actually learn more about that. And another concept we may want to teach students is how, even if the input is machine readable, computers still don't naturally understand meaning or what to do with the input. And so one great way to teach these concepts are actually through allowing students to build their own conversational agents. Like with the blocks in the App Inventor interface, which shows intents, which define meaning, and endpoint functions, which define what computers do with that meaning. And yet, although this type of intent classification is useful for level 2 agents, it's also important to teach how this process is currently evolving and likely to change in the future. So for level 3 assistants, intent classification is likely to be a thing of the past. And so it's even more important to teach the basic concepts of conversational AI, like how agents don't naturally understand human speech or language, but that humans can actually program them to or train them to using different techniques, like intent classification, for example. By teaching current methods to create conversational agents and the problems associated with these methods, more people will be able to start thinking about these problems and come up with new ways to actually solve them. And then finally, another important concept, especially for level 3 agents, is that computers need to store information from conversations in order to bring it up later and engage in natural conversations. And so one example of a way to teach this is actually by enabling people to curate the data sets that the agent is learning from and see how changing these data sets affects the agent, like we said before, or saw before with Zorai. And what I think is really of the utmost importance is teaching people the ethics of what it means to be developing and using this technology. So for example, how can they create something socially useful and provide these people with time to think about any unintended consequences of the technology they're developing or thinking of using. And so in the pilot study with Zorai, we actually had discussions about ethics and ask questions like, is it okay if we teach Zorai something that isn't true about an animal? And what if we actually taught it something untrue about a person? How would it make that person feel? And other important concepts about conversational AI include how computers follow instructions, how they can be very simple or very complex, like differentiating pictures of cats and dogs, which actually leads into the next concept that's important to teach people just about artificial intelligence in general. And so the core concepts of AI perception, for example, learning, representation and reasoning, natural interaction, social impact, which are actually the big 5 AI ideas by a paper with Turetsky that you can find on the AI for K-12 website. And this is a really, really great resource, just looking into what we think people should know about artificial intelligence in general. And then also, it's really important to teach people about how to create effective conversational agents that are flexible, concise, correct, relevant, natural, which you can learn more about through Grease's principles or other UI design principles, and teach people as they're developing their own conversational agents. And so one way we taught students the concept of flexibility was through the Alexa Skills interface and adding more training data to the system, which you can actually see here in the block at the bottom. There's those pink blocks with hi, hey, hello, which actually enable Alexa to be more flexible and understand more phrases. So all in all, as we're learning how to create more complex and effective agents, let's make sure others understand how they work, what living in this AI-filled world really means, and really have access to the power that the technology provides. Because providing access brings diversity to developers, which leads to new ideas, innovation, and equality. And so just to further motivate teaching and learning about conversational AI, here are some quotes about what types of conversational agents students would develop. Everything from automatic 3D modeling tool to a statistic retriever to counseling services. And so I'm really excited about what they end up developing in their futures, and I hope you are too. Here's just a summary slide with a couple different links if you want to learn more. So I hope you enjoyed listening, and all the best with your conversational AI development.